Welcome Calculus. This is section 8.5 partial fractions. The essential question is, what's a partial fraction? Let's begin. So sometimes we have a fraction and we want to break it down to smaller fractions. This is what we call the method of partial fractions. So I have this big one, 1 over x squared minus 5x plus 6, and actually is equivalent to 1 over x minus 3 minus 1 over x minus 2. And if you don't believe me, watch what I do on this side. So I'm going to multiply this fraction by x when I have the like denominators. So x minus 3 over x minus 3, and this one by x minus 2 over x minus 2. What you'll get on top here is you get x minus 2 minus this whole x minus 3 quantity over x minus 2 times x minus 3. And if I combine like terms at the top, I have an x minus an x, which will be 0, and negative 2 minus negative 3, so plus 3, which will be positive 1. And foiling this out, you'll actually get x squared minus 5x plus 6, which matches this side. So cool! You can believe me if they're equivalent. Which would be easier to integrate? This one? Nah, you don't know how to do that. There's no u if you try the x squared plus 5x plus 6. That doesn't work out. But these ones would be easier to integrate. Because I can say integral of 1 over x minus 3 is going to be natural log of x minus 3. And this one's minus natural log of x minus 2 plus c. Much easier to integrate. So how do I turn this one into this? And that is doing partial fractions or fraction decomposition. So if you recall from algebra, you can factor polynomials. And so you could take something big like this. And we can factor it using all sorts of methods. This one uses factoring by grouping. And then it's doing difference of squares right here. This turns into x squared minus 1, x squared plus 1. And this x squared minus 1 actually is x minus 1, x plus 1. So, and which you have duplicates right here, so we can write the factored form as this. Well, we use that to actually decompose fractions. And here are the steps of walking through this. So the first step, you're going to have to do polynomial division when the numerator is greater degree than the denominator. So in the example that we started with, the numerator degree is 0 and the denominator is 2, so I don't have to do polynomial division. If I had to do a different problem like x cubed over x squared minus 5x plus 6, this is 3 and 2, I would have to divide first to get my correct, to do a form where I could actually decompose. Luckily, I'm going to avoid that for now. So factoring this one, I want to actually factor the denominator. So x squared minus 5x plus 6, and however you like to factor. Some people like doing this method. I don't care what you do, and maybe you just do it in your head, and you get x minus 3, x plus 2, or x minus 2. All right, now I want to write out the decomposed fraction. So here's the format. Your original fraction is going to be equivalent to each of these factors having their own fraction, but we're going to put a constant on top, a plus b plus etc. So all the way down the line. If you have multiple different terms, like if I had an x plus 4 for some reason, I would say c over x plus 4. But I do not have that, so I will not do that. Great. So now that I've decomposed, I got to figure out what a and b are, and that's my last step. So how do you start this? Well, the first thing, I don't like fractions. So I'm going to multiply everything by whatever the common denominator. The common denominator is x squared minus 5x plus 6. Now another way to write that is the factored form x minus 2 times x minus 3. No one's in here? X minus 3 times x minus 2. All right, what cancels out? Well, on the left side, these two cancel. I'm left with 1. For the first term, x minus 3's cancel. I'm left with a times x minus 2. And on the right term, the x minus 2's cancel, so plus b times x minus 3. Now I want to solve. And all you do is solve is you substitute in different values for x. And I'm going to pick in values that actually get rid of letters, because I want to get rid of a letter to solve for the other. So first I'm going to say x equals 2 to get rid of the a and solve for b. So if x equals 2, 1 equals a times 2 minus 2 plus b times 2 minus 3. 2 minus 2 is 0, so that goes away. So your 1 equals b times 2 minus 3, or b times negative 1. This means my b equals negative 1. Cool. Now I got to solve for a. We're going to do the same thing. Instead of x equals 2, say x equals 3 to eliminate the b. So 1 equals a times 3 minus 2 plus b times 3 minus 3, which is 0. So 1 equals a. All right, so I can write my decomposed form of the fraction as 1 over x minus 3 plus negative 1, that'd be over x minus 2. And if you'll notice, in the original slide, that's what we said that was. 1 over x minus 3 will minus 1 over x minus 2. And you can integrate. So that's how you decompose a fraction. Let's do another problem. So let's look at this one first. If I want to solve this, what I'm going to do is I want to factor the bottom. So do second degree on top, third degree on bottom. I don't have to divide. Let's factor this bottom. And this factored on the bottom form, well, I can GCF is going to be x. So I can write this as x times x squared minus 2x plus 1. And this is going to actually factor into x times x. Oh, that's going to be plus 1 squared. All right, so that's my factored form at the bottom. Now I'm going to write the decomposed fractions. Now there's a difference here when I have a squared. All right, so I'm going to write the fraction 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x. It's going to equal a over x. Now we have x squared. We're actually going to do two separate terms. So I'm not going to do like a b over x plus 1 and a c over x plus 1. Do b over x plus 1. And I'm going to do plus c over that x plus 1 squared. So I have to solve for a, b, and c. I'm going to do the similar things as before. So both sides, I'm actually going to multiply by, the factored. Everything by x times x plus 1 squared. Okay, so what happens here is you're just left with the numerator. 5x squared plus 20x plus 6. And then a, if you're only getting rid of the x, you're left with a times x plus 1 squared. And the b is only getting rid of one of the x plus 1, so it'll be b times x plus 1. And the c, you get rid of both the x plus 1s, so it's just c times x. Cool. Now I want to solve. So just like you did before, you're going to pick values. You try to solve for each of these, start with what's easy. If I set x equal to 0, the b and the c are going to cancel out, and I can solve for a. So if x equals 0 is my first guess. Setting x equal to 0, the left hand is going to be 6 equals a times 1 squared plus 0 for the c. So a equals 6. Now the next thing I want to do, what else is going to be easy to solve? I want to solve for the c. I can solve the c by making x equal negative 1 because the a and b will cancel. So x equals negative 1. I'm going to write this as 5 times negative 1 squared plus 20 times negative 1 plus 6 equals, setting that to a equals negative 1 is going to be 0. Setting this to negative 1 will be 0 plus c times negative 1. So doing the math here, this is going to be 5 minus 20 plus 6, which is going to be negative 9 equals negative c. So c equals positive 9. Cool. I got a, I got c. Now b is the weird one. So what I can do is just plug in my a and b, and I can plug in some value for x, and I can solve, or a and c, and then solve for my b. So I'm actually going to erase some of this because I want to do the work up here. So I know my a equals 6. I'll write that down. A equals 6 from before. Let's do the work up here. So let's pick a value for x that also doesn't cancel out the b. We can make x equal to 1, positive 1. Something simple. So it'll be 5 times 1 squared, or 5, plus 20 plus 6 equals a. So 6 times 1 plus 1 squared, 2 squared is 4, plus b, which we don't know, times 1 times 2, plus 9 for c times 1. Doing the math here, 25 plus that is 31 equals 24 plus 2b plus 9. 24 plus 9 is going to be 33 plus 2b. Subtract 33, get negative 2 equals 2b. So b equals negative 1. All right, I got everything. So I can write my final answer, and I'm just going to erase this because I want to write it up here, is going to be, decomposition is going to be 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. That's the decomposition. But wait, what was the point? I have to integrate. So I'm going to erase some of this work. And now I actually want to integrate each of those. So hopefully it's not too bad. The integral of this, so instead of, I'll write it again. 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. The integral of this, of the 6 over x, is going to be the 6 times natural log of x minus natural log of x plus 1. Now on this last one, you have to, it's going to be use substitution here, but you're going to get negative 9 over x plus 1. Think about the integral 1 over x squared equals negative 1 over x. It's similar to that because use substitution. So negative 1 plus c, this is going to be your final answer. A lot of work. Okay, we have more examples, but that was a really long example. We'll try this anyways. Pause the video. Okay, so we're going to decompose this. We're not going to solve. So decomposing this, it's already in factored form. It's a over x plus b over x squared plus 1 plus c over x squared plus 1 squared. Sweet. Next one, pause the video. All right, polynomial division first. Oh, gross. We're going to save that for class. Bye.